welcome to Cocoa Break with Microchip Technology. If you've joined us before, I usually introduce the episodes as Coffee Break. For this last episode of the year, we call it Cocoa Break. We like to take a slightly lighter approach. We've got some lights in our studio, and we'll actually be joining another facility where they're having their holiday party. I'm your host, Eric Latfelter. Joining me in the studio today is Aaliyah Fahout, our moderator.
Hi everyone, thank you for joining us for today's Cocoa Break, and you can participate in today's episode by leaving your questions in the comments in the chat, or you can email us at livestream@microchip.com after the broadcast. Don't forget to follow us on LinkedIn and subscribe to our YouTube channel. Back to you, Eric.
Thanks, Aaliyah. Our topic today is Microchip in the Motor City. Joining us from Detroit is Richard Herbert, Automotive Networking Product Marketing Manager at Microchip. Richard, welcome to the program.
Hi Eric, glad to be here.
All right, before we get started, we refer to Motor City in the title of our episode today, and you're in Detroit. For those who may not be most familiar with that colloquialism, can you explain why Detroit is called the Motor City?
Yeah, I think the reason goes back over 100 years to the birthplace of automotive manufacturing, and it kind of happened around here with some of the original Ford family creating the Model T, and up to today where we have Ford here, we have General Motors, we have Stellantis, we have the whole supply chain that sits around them. So the T is going out from Detroit into the surrounding states and into Canada as well. So it's all focused around here, a little bit like Silicon Valley, but to an automotive-centric customer base.
Thanks, Richard. Okay, so we've talked on this program and elsewhere, we talk a lot about how automobiles for decades have been marvels of mechanical engineering, and today and going forward, they are also marvels of electrical engineering and software engineering. So you mentioned the ecosystem. Can you talk a little bit about how all of that expertise is distributed throughout the ecosystem?
Yeah, it's an interesting question, and I think over the last few years we've seen a broadening of the scope and horizons of what an automotive platform would be. In the past, we've had internal combustion engines, and those have moved to have also electrified platforms as well. So batteries, hybrid platforms, and then on top of that, we also have the advanced driver assist, and even in the future, we'll have more autonomous driving. But the ADAS platforms demand a lot of very cutting-edge technology, because those are the platforms that have to make essentially road decisions for the vehicle and operate the system. So we see this splitting of the platforms into internal combustion engine, into battery-based electric vehicles. But then on top of this, we also have this platform which includes a lot of advanced networking technologies and high-performance compute as well.
Okay, so to support all of that required expertise, we've opened the Detroit Automotive Technology Center. Can you give us an overview of the purpose of the center and just a little bit about the facility?
Yeah, as the automakers wanted to get closer to the architecture and design, then we felt there was a need to help them focus and provide some support to them. So the Detroit Automotive Technology Center has been opened this year. So this is part of the grand opening. That's why we're here today. But we wanted a base where they could come to us, the tiers could come to us. We can talk about architectures, designs. We can talk about evaluation boards and systems, and go through all these issues with them. So it's not just hardware, but it's software. It's the electrified side. It's the advanced systems and networking side. So we wanted to have this close to them, and it'd be a base where they can actually come in and do some useful work with us.
Great. Can you take a walk around and let us have a look around the facility and maybe give us some examples of how we're engaging with customers at the facility?
Yeah, sure. Let's go. We're in full party mode. All
right. While Richard is doing that, a couple of points about the center. There are dedicated high voltage labs and human machine interface labs. There's support for central compute and zonal networks. There's USB and networking development resources. They're able to support die and product level characterization and the development of automotive security solutions. Pick back up with Richard.
Hi, Mike. Why don't you introduce yourself?
Hi, my name is Mike Friel, Field Application Specialist at Microchip's Detroit Automotive Tech Center.
Why is hands-off detect so important for autonomous vehicles?
Most advanced driver assist systems require the vehicle monitor driver behavior and issue an alert if the driver removes their hands from the steering wheel.
How does hands-off detect work?
Our solution is a capacitive touch-based solution that is able to reliably detect touch all the way around the steering wheel, similar to how your capacitive touchscreen works on your cell phone.
Why is ours so special?
Detecting touch on a large sensor like a steering wheel is difficult compared to a small button. So we've developed specialized algorithms and circuitry to address this challenge. We provide a very low-cost total system solution that's able to meet the stringent test requirements of the automotive industry, including things like moisture immunity. So the system continues to work if I were to spill my hot cocoa on the steering wheel.
Are there other things we can use to detect drivers?
Sure. So in addition to capacitive touch around the steering wheel, we also implement Microchip's inductive sensors to detect steering wheel position. The accuracy and resolution of the inductive sensor allows us to detect very minor changes in position, which would indicate somebody's holding the steering wheel.
Thank you, Mike. Let's go and talk to Sal. Hey, Sal, why don't you introduce yourself?
Yeah, hi, I'm Sal Canu. I'm a wired networking specialist here at the Microchip Detroit Automotive Tech Center, and I focus on the next generation Ethernet single pair devices.
What does the next generation Ethernet network look like?
Yeah, so Ethernet is coming into the vehicles here because of the complexity due to the new architectures and new features such as driver assistance. So and the other thing with automotive is that different than the home and business, Ethernet in the home and business has 4 twisted pairs, whereas Ethernet, it's a single twisted pair. So that saves on weight and cost.
How does Ethernet fit into the next generation network?
Oh, that's a good question, yeah. So today's vehicles have CAN and LIN and other protocols like that. There's some bandwidth limitations there, and it's also difficult to convert data from one network to the other. But if you move over to Ethernet, which that's what we're doing here in the future vehicles, then you've got Ethernet all the way from the high speed area where the central computer is over to the end nodes where there's lower speed requirements. You've got that same Ethernet frame through all of those networks. It's very easy to convert from one speed to the other, and that saves on a lot of data processing.
So if data goes to the central compute, how do you keep track of all this data and keep it in order?
Right. So Ethernet, it was a protocol that you didn't know when messages may come in, and for certain applications, you've got to know that time. It's very important. So there is a standard called time-sensitive networking. With that standard, there's a timestamp for all the data going out, and the system has a master clock that's shared throughout all of the zones and endpoints. So with that, you've got very deterministic behavior, very important. So for example, let's say you and your band just recorded a new hit version of Jingle Bells, and you wanted to share that with all your fans. So you could stream that out over Ethernet using time-sensitive networking, and you will have no glitches or grinches to worry about.
Thank you, Sal. Let's go and talk to Brad. Brad, why don't you introduce yourself?
Well, hi, I'm Brad Harris. I'm a high-speed network and security specialist in our Detroit Automotive Tech Center.
Why is PCI Express needed to connect the vehicle brains?
Well, with modern vehicles, the vehicle today is like a data center on wheels, and with autonomous driving, there's gigabytes of data being moved all around the vehicle, and that data requires low latency and high reliability, so PCIe fits the bill.
What demo do you have in?
Well, today we're showing off our PCIe switches, and what we're actually showing you is Microchip also has under the hood here bridging devices, because sometimes you need to bridge from USB or Ethernet to PCIe. So we are bridging from USB on this camera to PCIe, and it's coming through here on an automotive grade cable. This is about 7 meters of cable. So we're showing that we can send a PCIe data over long lengths in the vehicle, and then it's coming to this switch, and it's being displayed on the monitor here. So we have a live video feed.
How would you normally connect PCI Express over?
Typically, it's PCB traces, well laid out traces, but in the vehicle, when we're starting to see, the architecture of the vehicle being more spread out from different modules, we are seeing cables just like this in the vehicle routing PCIe data.
Thank you, Brad.
All right, cool. While Richard's gone back to his desk, if you go to our Automotive Solutions page, you can see information on the screen about the Detroit Automotive Technology Center and a link to the press release, which has more information about the opening of the center. Thanks, Richard, for the tour. Love seeing the ugly sweaters and the hats. Hopefully your holiday party's going well. Maybe could you just close out a little bit by talking about the staffing there? It looks like there's some real deep expertise on hand.
Yeah, the Detroit Automotive Technology Center has a pretty broad role in the automakers industry here. So you saw there the applications engineers we have, which those aren't the only ones, actually more than those, but those guys have that specialism in some of the core technologies. We have a sales team here as well, supporting the commercial side of the industry. We have several people from BUs representing both engineering and marketing functions here. So in terms of the support that we have, it's on a fairly broad base, covering a lot of different technologies, a lot of different businesses, and all focused on the automakers and those tiers.
Great. Thanks for the overview and thanks for the tour. At this point, let's go to Aaliyah and see if we have any questions from our viewers today.
Yes, I do have a question from Alyssa. This is from YouTube, and she'd like to know, how long has Microchip been in Detroit?
Yeah, Microchip's history in Detroit goes back more than 2 decades. So in 1999, the first office was opened here. There was only a few people back then, but we've moved a couple of times and, of course, increased the staffing levels to where we are today. We're coming up to about 40 people with the increase in floor area and the 2 labs that we have now. So it's over 2 decades of history in Detroit already.
Awesome. Here is an email question from Kumar. How much power is in the SICK lab?
The SICK lab was installed with the infrastructure to be in place to support 31 kilowatts. So 31 kilovolts over 480 and 208 volt feeds. So we actually made a big point when we were setting up the lab and creating it with the building management to make sure we had the appropriate infrastructure and power in place to support some of those big powered systems.
Awesome. And here is another YouTube question from Mahi. Where is Ethernet used in a vehicle?
That's a good question. And we spoke about the evolution of vehicle platforms earlier. So putting aside the whole internal combustion engine versus the electrified platforms, then you have on top of that the platform that supports the advanced driver assist and even the autonomous functions in the future. So what we're seeing is that the need for data within the vehicle is increasing, not just from sensors on the edge, so temperature sensors, vibration sensors. The amount of camera data that's coming into these vehicles now is huge as well. You have to connect these all up in a standardized way, and it's all about having standardized approaches to technologies. So IEEE Ethernet is something that's supported from 10 megabits per second up to gigabit speeds on the backbone. But this is at the expense of maybe a reduction in the amount of CAN interfacing. So we're seeing Ethernet used across almost every surface in the vehicle, connecting the edge to the cloud and the cloud to the edge for doing things like software updates, as well as sharing data between different processing elements in the vehicle. So the transition to Ethernet has begun. It's been there for several years now, but the transition to a fully Ethernet vehicle is the stage that we're at now, as it starts to supplant many of the CAN nodes that are already there.
Great, thanks, Richard. And this one is an email question from Emily. Does Ethernet replace something in today's cars, or is it in addition to other technologies?
So it's a transition, and at the moment, Ethernet and CAN, traditional automotive CAN networks, are going to coexist for a long time, but the move is in place to adopt more Ethernet nodes at the edge, and one of the candidates will be the adopting Ethernet where CAN nodes used to be. The data throughputs that you get with Ethernet at lower rates and the guaranteed connectivity and the point-to-point routing of the data through the network means that there's less need or less use to be made of CAN networks and more use to be made of Ethernet networks with some of the more advanced features that you have. And of course, all the car makers are now adopting car as a service and some of these semi-autonomous platforms. So the need for data in the vehicle is increasing, and Ethernet is the way to do that.
All right, thanks, Richard. Here's a question from Naveen on LinkedIn. What's the FPS running on that monitor video?
Oh, sorry, which one was that?
What's the FPS running on that monitor video?
The frames per second on that monitor video. That was the camera demo that Brad had. That was, I think, the full 30 frames per second from a web camera. It wasn't a full automotive camera. It was a demonstration platform. So it was a simple USB webcam that we had plugged into the board on either side.
Great, thanks, Richard. I have, I believe, a few more questions for you. Trevor from LinkedIn is asking, what does sensing a hand on the steering wheel do for vehicle safety?
That's a good question, because certainly as the move to more advanced driver assist and semi-autonomous functions happens, then there's a need to know when a person is engaged with the vehicle. So whether that's visually with eyes on or with hands on or hands off, then this is a very important element to decide when the vehicle takes control of the vehicle systems or has to release the vehicle systems to the driver. So there's a very big functional safety element of hands-on detect and other occupant detect systems.
Great. Last question for you, Richard. This one is from Ernesto from LinkedIn. What type of vehicles and what technology requires all the extra bandwidth of PCIe?
It's interesting that what we see today is that even with vehicles adopting level 2 autonomous features, so even those are starting to increase the demand for performance and processing in the central compute. And we're seeing that as being an evolution from today where we are to in the future with level 3 plus, more advanced driver assist features all the way through to autonomous, which is a bit further out into the future. But when you start to have these very complex high performance SoCs and you have all this camera data coming into those same places, then the need for having a very high speed data network to share data between processing elements in a very low latency way, it is very important. And that's where PCI Express comes in. So again, it's a standardized network. It's PCI SIG defining it, but you need to have this very high speed, very low latency local way of sharing data between these either SoCs or a camera and an SoC, or an SoC and a solid state drive for a black box. And PCI Express is pretty much the only technology that will give you the high speed network with the low latency, but it's very localized to that high performance compute part of the system.
All right, it looks like we have one more question, Richard. This one's coming from Rick on LinkedIn. Will LiDAR continue to be the proximity sensor of choice when cars become more autonomous?
I think that's an interesting question, and I think that's a divide in the industry. So LiDAR for certain at the moment provides this 3D depth perception that maybe you have to do in a slightly more complex way with cameras. So you do have these two competing technologies in vehicles, and OEMs, automakers have different approaches to both of them. In the short term, then LiDAR has been established there as the depth perception of choice for many OEMs, but there's also OEMs that are doing triangulation between different cameras to actually work out what the depth of an object is, or what the distance from the driver to an object is, doing it with visual images. So I think in the short term, then yes, they're going to be there. In the longer term, it becomes an issue of cost and economics and mechanical reliability. And if those can be solved, there's no reason why LiDAR can't carry on. But obviously, there'll be a cost crunch at some point, and maybe cameras become cheaper. So let's watch the industry and see what happens.
All right, thank you, Richard. Those are all the questions I have for you today. And for the audience, if you have additional questions or comments, please email us at livestream@microchip.com. And don't forget to follow us on LinkedIn and subscribe to our YouTube channel. Back to you, Eric.
Thanks, Aaliyah. Thank you, Richard, and thanks to the team at the Detroit Automotive Technology Center. Thank you to our viewers for taking some time to join us today. This is the last episode of the season and the last of the year, but we have a full schedule planned for 2024. Please visit us at microchip.com/coffeebreak You can sign up for subscription, so you'll see when that information on the next seasons are posted. And you can peruse our library of previously recorded sessions, now up to about 60 different topics. Thank you again, and we hope to see you in 2024.